Hi everyone, we're here to talk about 5G and the changes made by 5G. My name is Ehsan and I will be representing this research with Amandip, Wishish and Smith. I split the topic into almost 8 main titles. First, we will talk about introduction to 5G and the features and concepts of the 5G. After that, we will explain how 5G works and what is the 5G network infrastructure that needed. And after that, it will be the advantages and applications of 5G and also future scopes and challenges ahead with this technology. And at last, it will be the conclusion. Introduction to 5G. It's the fifth generation of cellular technology, and it promises to greatly enhance the speed, coverage, and responsiveness of wireless networks. But how fast we're talking about? We're talking about almost 1 gigabit per second, which is 10 to 100 times faster than your typical cellular connection, and even faster than anything you can get with a physical fiber optic cable going into your homes. We are talking about complete wireless communication with almost no limits. Mobile and wireless traffic volumes will increase 1,000 times and can be called real wireless world, which has incredible transmission speed. Think about a world like in which not just people but all things are connected. Cars to the roads, doctors the personal medical devices of their patients, augmented reality, and everything. This thing requires a massive increase in the level of connectivity, and 5G is the technological answer to that, making possible billions of new connections and also making those connections secure and instantaneous. We all know that 5G will impact every industry like autos, healthcare, manufacturing and distribution, emergency services, and etc. And 5G is purposely designed to do that. So the industries can take advantage of cellular connectivity. Let's take a brief look at evolution from 1G to 5G. First generation was developed in 1980s and completed in 1990s. It was based on analog system and a speed up to 2.4 kbps. The second generation was completed in late 1990s and it was based on digital system and speed up to 64 kbps. The third generation came in early 2000 and transmission speed was 125 kbps to 2 mbps, which is very good compared to 2G, and the voice quality was much better. And the fourth generation, which we already using it since 2010, it's faster and more reliable, speed up to 100 mbps, high performance, easy roaming, and low cost. If you take a look at the right side table here, we can see that the difference between 5G and 4G is with three major parts of bandwidth, technology, and services, because multiplexing, switching, and core network handoffs are the same for 4G and 5G. But for bandwidth, we can see that for 4G we have 200 Mbps, but with 5G we can reach more than 1 gigabit per second. And also the technology is for 5G, we get for all the things with 4G plus worldwide wireless web. And for the services, we have the same services with 4G, but the difference is we can have the devices with AI applications, which needs very high speed connection. If you take a look at these figures, we can see the different focus area of 4 technologies. With 2G, 3G, and 4G, the focus was only about speed and throughput. As you can see, 2G was only about voice and short message services, and 3G and 4G was upgrading that plus having a better speed and throughput. But with fifth generation technology, not only speed and throughput will be covered, also we will have a very high connection density and very low latency and delay at the same time. Why 5G? Why do we need 5G? Because it will provide us with enormous novel technology features like worldwide cellular phones, like extraordinary data capabilities, very high connection density, wider network coverage, more power and features in handheld phones, large phone memory, more dialing speed, more clarity in audio and video, and also is capable of supporting worldwide wireless web. 5G has a lot of features and concepts like zero latency, speed up to 10 gigabit per second, wide range of applications, more software options for upgrade, very high capacity, faster response time, etc. and etc. And in here, we will explain some of the most important features of the fifth generation. Speed upgrades. Each wireless network generation has reflected a major increase in speed, and the benefit of 5G will push far beyond 4G LTE. With 10 gigabit per second of speed, we will have 100 times faster network than 4G. Now, what about low latency? What is latency? Latency measures how long a signal takes to go from its source to its receiver and get back. With 5G generation, we will have almost zero latency, let's say less than 5 milliseconds of latency. Also, we will have a bi-directional large bandwidth. 5G networks are designed differently from 4G, allowing greater optimization of network traffic and smooth handling of usage spikes, which lets us to have a very wide bandwidth in the network. And also, we will have a high connection density. 5G density will enable up to 100 times more connected devices in the same physical area of 4G, while like almost 100% availability of the network. This density may bring business advantage for mobile workforces. In real benefits is increasing the size of the mobile customer market.
5G operates on three different spectrum bands: low band, mid band, high band. Low band spectrum can also be described as a 1 GHz spectrum. It's a primary band used by the carrier in the US for LTE, and the bandwidth is nearly depleted. While low band spectrum offers great coverage area and wall penetration, high band spectrum can offer peak speeds up to 100 Mbps. Mid band spectrum provides a faster speed and lower latency than the low band. Mid band spectrum fails to penetrate building as effectively as low band spectrum. It can offer a peak speeds up to 1 Gbps. High band spectrum is what delivers the highest performance for 5G. High band spectrum can offer peak speed up to 10 Gbps and has extremely low latency. The main drawback of the high band is that it has a low coverage area and the building penetration is poor. Now let's see how 5G works. Like other cellular network, 5G network uses the system of cell sites that divide their territory into a sector and send the encoded data through radio waves. Each cell site must be connected to a network backbone, whether through a wired or wireless connection. 5G network use a type of encoding called OFDM, orthogonal frequency division multiplexing, which is similar to the encoding that 4G LTE uses. The air interface is designed for a much lower latency and a greater flexibility than LTE. Though with the same airwave as 4G, the 5G radio system can get about 30% better speed. While lower frequency are occupied by 4G, by TV stations, by satellite firms, or by military, there had been a huge amount of essentially unused higher frequency available in the US, so carrier could easily construct wide roads for high speed. Qualcomm says 5G will able to boost capacity by 4 times over a current system by leveraging wider bandwidth and advanced antenna technologies. There are two infrastructure options for 5G network: non-standalone infrastructure (NSA) and standalone infrastructure. A NSA infrastructure relies partly on a existing 4G LTE infrastructure and brings some new technology like 5G New Radio (NR). Non-standalone architecture has the 5G radio access network and the 5G new radio interface working together with existing LTE infrastructure and a core network. Standalone infrastructure refers to a 5G network that does not rely on LTE network and has its own cloud native network core that connects to the new radio. It is expected that network carrier will arrive at the standalone infrastructure after moving through an NSA non-standalone infrastructure. Using a non-standalone infrastructure approach allows a carrier to offer a 5G-like experience while they build out the needed physical infrastructure of 5G network. The standalone deployment option is composed of user equipment, the radio access network, which includes the new radio, and the 5G core network. The 5G core network relies on a service-based architecture framework with virtualized network function. 5G network infrastructure is made up of macro and small cell base stations with edge computing capabilities. Macro cell are traditional cell towers that serve a wide area. In a 5G network function that typically runs on hardware become virtualized, running as software. Before 5G network reach their full potential and become a self-sufficient, more carriers will be using existing 4G LTE radio access networks, augmented with some new antennas. This allows carrier to begin offering improved service while the new physical infrastructure is built. Small cells. Small cell base station is a 5G infrastructure require a considerable amount of construction. These antennas takes up less real estate and are designed for a device dense area such as urban settings and to blend in with the existing landscape. These small cell antennas transmits and receive the higher band radio frequency spectrum with millimeter wave frequencies. High band frequencies can carry more information faster but over a shorter distance. As such, they do not cover much area and must be densely arranged. Beamforming is used to help expand the millimeter wave signals reach. Radio signals are made into focused beams directed at the target. The goal is to maximize the signal quality while avoiding interference from other radio waves. Radio Access Network Cell Tower RAN. The RAN is a key element of cellular communication and plays a role in covering medium and large geographic area in 5G networks. 5G RAN focuses on mid and lower band radio frequency like a 6 GHz frequency that can cover a larger area but carry less data. That's why this part of 5G infrastructure will be more often used for a less populated area where there is a less network congestion, allowing for higher speeds with a more dispersed infrastructure.
Let's talk about advantages of 5G. As one of my team members explained about the features of 5G, those features provides so many benefits over previous generation, but the major advantages are faster speed, shorter delay, increased connectivity, IoT machine learning or artificial intelligence improvements, etc. etc. So now let's take a brief look on these advantages. Faster speed. Data transfer speed are projected to be about 10 times higher with the 5G than the previous 4G. That means significantly faster transmission of images and videos. With the 4G, downloading a high definition movie might take about 6 to 10 minutes, but with the 5G it's only about a less than minute. Next, shorter delay. Though is not always noticeable, there is often a brief lag in the time from when data is sent and when it's received. 5G should reduce this so-called latency. Latency is also described by one of my team members already, making it possible, for example, to watch high-speed virtual reality video with the no delay. Then, next is increased connectivity. Cell towers equipped with 5G technology would have greatly increased capacity over 4G. That means that will cover more people and more devices should be able to communicate at the same time. 5G network will help the power of the huge rise of IoT. 5G will facilitate much wider adoption of the artificial intelligence. One of the biggest barrier of the AI adoption has been limited processing speeds. 5G promises that to deliver data transfer speed 10 times faster than 4G ever could. This means that system using AI application will be able to receive and process data much faster. This will impact machine learning as system using AI application will be able to analyze data much faster, thus the learn from it make this necessary improvement much faster. According to all these advantages, let's talk about a case of downloading something file from the Google. Consider an example of downloading one 2-hour full HD 3D movie from the Google, which is comparatively a very large file. As per 4G speed, it will take approximately 6 minutes, but in 5G, it only takes 3.6 seconds. That's nothing. Let's talk about application of 5G. The 5th generation mobile communication network, thus called 5G, will not only be the faster than current 4G, but also has the ability to revolutionize other sectors such as infrastructure, production, automotive, healthcare, and energy. Some of the applications of 5G are smart cities, virtual spaces, telemedicine, driverless cars, the world of work. Let's talk about smart cities. 5G is enabling technology for IoT, and as a smart cities, it's essentially rely on IoT. 5G and smart cities are interconnected links. The smart home is a good model for understanding the potential impact of 5G. Just because you may have asked a digital personal assistant to order more toothpaste, or you may have monitored your vital and charted your exercise goal with the fitness tracker. Maybe you turn on the lights and adjusted your thermostat before you enter through your front door. But that's the just table task. Let's think about more massive IoT applications. The kind of up and old business models and create new ones are another thing entirely, and we are getting closer to the relative. Moving beyond the home, we can now imagine the smart offices, smart cities, smart factories, etc. etc. Managing the resource and operation so many large cities can only be cost effective and efficient when it is automated or it's connected to each other. The creation of smoother and safe living through the gradually digital transformation is already beginning. Sensors must be placed everywhere to collect data. The massive amount of data generated by this sensor needs to be communicated and analyzed and fed back to the infrastructure to affect changes in the operation of smart cities. As an example, Barcelona's sensor-embedded parking spots already connected with the application that communicate directly to the driver about the available spaces. Projects are also underway in the cities including Amsterdam, Copenhagen, Columbus, Ohio to realize the smart city version as well. And these smart cities features also include some of the basic IoT applications like smart city system, check on crimes, better traffic management, low powered sensor, etc. etc. Let's talk about virtual spaces. We know that 5G will bring a massive increased mobile network speed, capacity, reliability and flexibility. 5G will also have lower latency facility, which means it's better responsiveness time. In this case, it refers to the time taken between request and response. Lower latency is what is the main necessary for virtual reality and augmented reality. In short, a real 5G network will help VR and AR application evolve to the next level. Because of this all the benefits or advantages, it's possibly to develop some advanced level applications like smart glasses, smart office, real-time translation device, stress busting wearing device, VR and AR enhancement applications.
Another application of 5G. It's telemedicine. 5G will open the new dimension for the field of health and medication. Telemedicine would be a reality. 5G will facilitate flawless communication between you and your doctor with low latency and HD quality wireless network to take it to truly virtual appointments. It would be enhanced by wearable or implanted medical device. Today, the watch on your hand can do beyond a traditional watch. It can measure your ECG and heart rate and report it to your doctor. Imagine getting a mini diagnosing device delivered at your home for your virtual appointment with your doctor. These devices can be controlled by the doctor to capture the reports. High-speed wireless network will also enable the telesurgeries. In fact, the year 2019 witnessed it. A doctor in China removed part of a pig's liver from 30 miles away using a 5G connection, which speaks for telesurgery. Specialists from one hospital would be able to control the medical equipments in another hospital from hundreds of miles away. Driverless cars. Imagine you wake up, grab your cup of coffee, and drive to your work, but wait, you don't have to drive. You can read, work, or maybe sleep. That's what 5G will bring you closer to. Everybody has heard about driverless cars. Not only tech companies like Google, Tesla, but also mainframe auto companies like BMW, Mercedes are ready with their prototype of driverless cars. But these cars have to do beyond driving without a driver. According to the National Highway Traffic Administration, nearly 95% of traffic accidents are caused by human error. With enhancement of 5G, vehicles would be able to communicate with each other, which would make human errors disappear. This in turn will also minimize the congestion on the road and would navigate you to your destination in shortest frame of time. In medical emergencies, cars would give out way to one in need. Also, cars would communicate with sensors on road or traffic light, which can potentially better assist the car with the road condition or warn you about the icy road ahead. The world of work. Perhaps 5G's broadest impact will be industrial and commercial IoT. Industries like manufacturing, energy and utilities, agriculture, retail, financial services, media entertainment will see huge acceleration in growth. The tracking on goods move from industries to end users by means of shipping and delivery will be more informative. Small scale factories will be able to automate and monitor the repetitive or dangerous tasks. With the ultra fast wireless network in the environment, it will be able to afford numerous IoT devices. It will be driver of fourth industrial revolution. Soil sensors and cameras will be able to identify the crop disease, reduce the pesticides usage, and know when to water the fields. Challenges. Let us talk about the challenges. Since market has just started seeing 5G devices being rolled out as flagship devices, it confirms the technology is pretty new for the mainstream user consumption. The old devices would not be able to support it, or maybe the hardware replacement on some devices would let them use the benefit of 5G. It will take significant time for most of users to replace their devices for 5G. Though the major telecommunications have started with 5G services, it is very much limited to major cities, and in fact, at some places, 5G is not even able to beat 4G. So it will take longer than expected for 5G to come with fully fledged range of services to benefit the users. Coming on to the conclusion. On one hand, where 3G is operator centric and 4G is service centric. On the other hand, we have 5G. The fifth generation wireless technology is user centric, which is to say, the technology is developed keeping the user as primary key in mind. With high transmission speed, low delays, and lower battery consumption, it is taking us to a better, promising future. There is no doubt that in the upcoming year, 5G will bring a new revolution in the wireless connectivity. Though for now, it is yet to mature. With the present footsteps of 5G in the market, the technology might look a bit expensive, which will come down as 5G will grow and soon it will be dominant in the market. The next 5 years will witness the spread of 5G, 5G compatible mobile phones, IoT device across the globe. It is not much far when we will have tons of sensors around us, electronics at our home talking to each other, VR and AR changing the way you meet people, automation driving you from home to office. In the end, we will conclude by saying that 5G is our step into the future. We will end the slides with a hearty thanks to the reference we took for the preparation of these slides.